All right, the next piece that we're going to look at is something called the law of sines. Okay, and the law of sines is something that you're going to use when you have an opposite pair in a triangle. Okay, well, what do I mean by that? Let's just scan down here really quick to some examples. So you need to make sure you have an opposite pair, meaning you need to make sure that you have an angle and the side opposite of it. Okay, so this one, I know this angle and I know the side off of it. Now this one, I'm looking at it, I'm saying, oh man, I don't have an angle and the side opposite it. But because I know these two angles, pretty easy to figure out what this angle is, right? So I can very easily use the fact that all angles add up to 180 to figure out this angle, and then I'll have that opposite pair, okay? So that's when you're gonna have the law of sines come into play. You have to have an opposite pair. Okay, so the first thing we're gonna do is I'm gonna show you where does this law of sines thing come from, okay? And then we'll establish what exactly the law of sines is, and then we'll use it. So this part up here is not something I'm gonna ask you to recreate. It's just to kind of show you like, okay, it does make sense where this thing's coming from. All right, so let's take a look at this triangle. So similar to what we did with the area, I'm gonna drop my height of my triangle here, and we know that's perpendicular because that's how altitudes work. Okay, and I will call this triangle ABC. And then using my opposite rule again, right? We'll call this side A, this side B, this side C, right? Just how we name angles and sides. All right, great. So using this, again, similar to what we did when we were looking at area of not right triangles, we can see how we've now split this big triangle into two smaller right triangles, right? So this guy right here is a right triangle, and then this guy right here is a right triangle. So what I can do from here is I can write two different equations that relate an angle and side H. Using this triangle, again, I can't use A because A is partly cut off, right? We cut off part of A. But I can say, well, the sine of C is H over B, right? So I can say that the sine of angle C is H over B. Okay, and much like we did before when we were looking at area, I'm going to solve this for H. So I'm going to go ahead and just multiply both sides by B to get this to cancel out. And then I can say that B times the sine of C equals H. Great. All right, now simultaneously, I can also say, well, if I look at this triangle here, I can also write a rule for the sine of this angle. Still can't use A because I still have part cut off, but I do have the opposite side and the hypotenuse. So I can also say that the sine of angle B is H over C. Okay, and then again, using that same logic, I can solve for H by multiplying both sides by C. And now I can say that C times the sine of B equals H. Okay, so all we've done so far is we've just figured out two different expressions that we can use that are both going to give us what H is. All right, and then since we know that if two things equal the same thing, if this equals H and this equals H, then there's a rule, a transitive property, that says that these two things have to equal each other, right? So from here, I can now say, all right, well, that means that B times the sine of C has to equal C times the sine of B. All right, and then this right here is technically part of the law of sines, but it's not really pretty or easy to remember. So what we kind of do here is we just rewrite this a little bit by dividing both sides. So I'm going to divide both sides by B to get this to cancel out. And then at the same time, I'm also going to divide both sides by C to get this to cancel out. All right, and all that's going to do is it's going to rewrite our equation so that it says the sine of angle C divided by however long side C is equal to the sine of angle B divided by however long B is. Okay, and that is what the law of sines says. It says that if you take the sine of an angle and you divide it by the length of the opposite side, you're going to get the same answer as if you'd done the sine of a different angle divided by its opposite side. Okay, and even though we drew this picture this way with this height here, we could have done the same thing using angle A. So it will actually work for all three angles in this triangle. So if I divide the sine of angle A by the opposite side, I'm also going to get that same ratio. Okay, so this ratio is always going to be the same, and then we can use that to make some conclusions. That's the whole point of trig, right? So my law of sines, what is technically the law of sines? So the law of sines just says that the sine of angle A divided by side A is equal to the sine of angle B divided by side B, which is also equal to the sine of angle C divided by side C. You don't need all three of these things. You basically just choose two of them, right? Whichever side and angle pair you happen to have, you tie those in. Okay, and then additionally, as one extra little thing, when we were doing this step here, dividing, we could have just as easily divided by the sine of C and the sine of B to cancel those out. And then the only thing that would happen is it would basically flip our fractions. So you can use your law of sines this way, but you could also say A divided by the sine of A is equal to B divided by the sine of B is equal to C divided by the sine of C. And you'll get the same answers either way. Okay, so if you flip them all upside down, you get the same ratio, right? Think about it. If it's 2 over 3 every single time, then if you flipped it upside down, it would be 3 over 2 every single time, right? So it's always going to work. You just have to make sure that all of the angles are in the top or all of the angles are in the bottom so that you're being consistent. All right, great. So let's jump down here and take a look at this. So this guy, we're going to find the side AB. So this guy at the bottom is what we're looking for here. So this is my unknown, and I'm just going to call that little c. Okay, so that's the side length that we're looking for. Now, like I said before, you only use a law of sines when you have an opposite pair. Okay, and we don't have an opposite pair here, right? The thing that I want, I know the angle opposite it, but I don't know this side length here to have both of the pair. So the first thing I'm actually going to do is just figure out what is angle A, because then I will have an opposite pair. And that's really easy to do because we know all the angles in a right and in any triangle add up to 180. So if I do 180 minus that 34 minus 110, okay, 36. So angle A is 36 degrees. And now I've got my opposite pair. 36 degrees and 20 centimeters are opposite of each other. Okay, so here's where I'm going to tie this into my law of sines. So the law of sines says that if I take the sine of this angle and I divide it by its opposite side, I will get the same thing as if I did the sine of this angle divided by its opposite side, which is what I'm looking for. Okay, I know I'm going to use the 110, not the 34, because the 110 is across from what I want. If I use the 34, I'd be able to find this side over here, but that's not what I was asked to find. Okay, so I'm going to use the 110 because that's across from what I'm looking for. All right, great. So now we just need to solve this. Now there are a bunch of different ways to solve this, but I find the thing that people remember the most is cross and multiplying. Okay, so cross multiplying just says that you multiply the things on the diagonals, right? So when I multiply the diagonals, this side, I'm going to get 20 times the sine of 110. And on this diagonal, I'm going to get c times the sine of 36. Okay, and then we can solve that pretty easy. So 20 times the sine of 110 is that number right there. So that's about 18.8 when you round it. And then when I want to solve that, I'm going to divide both sides by 30, or the sine of 36, right? So I'm going to divide both sides by the sine of 36 to get this to cancel. Okay, so I'm going to take my answer and just do divided by the sine of 36. Notice that I didn't retype that 18.8. You want to use the same answer that your calculator got and have it actually say just use that answer, because that's going to keep you from making rounding errors. Okay. All right, so that's going to work out to 39. That would round up to, so the 7 would round the 9 up. So this is going to round up to 32.0. Okay, and that is how long side C is. Centimeters for my units. All right, now this guy down here, we're going to do the same thing. All right, so here I want to find angle C. So this is my unknown here. All right, and if I want that angle, then I know I need the opposite side. I also have an opposite pair here. Okay, so what am I going to do? So I'm going to say, all right, well, the sine of the angle that I know divided by its opposite side, which I also know, is going to equal the sine of whatever my angle is divided by its opposite side. All right, and then we're going to solve this. Again, I'm going to use cross multiplication. So I'm multiplying on my diagonals. So the sine of 107 times 115, sine of 107 times, or sorry, regular 15, that's going to be 14.3. All right, and that's going to equal 40 times the sine of c. To solve this, I'm going to divide both sides by 40. So that's going to get the sine of c by itself. So I'm going to take my answer, divide it by 40, and I'm going to get 0.359 basically. Okay, and then from here, I need to figure out, okay, what is angle C? So this is where your inverse trig comes into play. So I'm going to say, all right, what's the inverse sine of that previous answer? If you have one of these graphing calculators, right, you use second and then your negative sign, that'll tell it to use your previous answer. Okay, and that tells me angle C is 21.0 degrees. Okay. All right, so there we go. That's how you're going to use your law of sines. And again, it works with anything. As long as you have an angle and its opposite side already, you can use the law of sines. But you have to have this pair, this known thing, to figure out what your ratio is in order to be able to solve. Okay, so you have to have the opposite pair. Now, one more quick note here is that you can only use the law of sines to find an acute angle, not an obtuse angle. So this one, it's okay that we used the 107, right? But if this triangle had been like, if they told us this angle and we didn't know that one, you can't use the law of sines there because there's this thing called the ambiguous case, okay? And basically what it is that there are pairs of angles that have the same sign. So if I say do the sine of a 30-degree angle, sine of a 30-degree angle is 1/2. Okay, well the sine of a 210 angle is negative 0.5. Okay, if you do the sine of 390, you're also going to get 0.5. Okay, so if you kind of see, there's like this cyclical pattern that's going to come around, and we're going to talk about that more later. But if you notice, there's two different angles that have the same sine. Okay, so when we were looking for this, if I had said, okay, well, tell me what the sine of the arc sine of 0.5 was, and the angle had been a 390-degree angle, your calculator is still going to tell you it's 30. Okay, your calculator is always going to tell you the smallest angle. Okay, so anything that's above 90 degrees, okay, anything above 90 degrees, you're going to run into a problem because it's going to be confused about what angle you're talking about. It's not going to know, well, do you mean a 390 angle or do you mean a 30 angle? Okay, so that's where you have to be the one to be smarter than your calculator. And just make note that you can only use the law of sines if it's an acute angle, so if it's less than 90 degrees.